All right, so chapter 5, section 1 is the triangle mid-segment theorem. And so we are going to feel like we are in triangles for so long now. It's going to be all about triangles. And this one has to do all with mid-segments. So what is a mid-segment? A mid-segment is just a segment that connects midpoints on two sides of a triangle. For example, if you look at this picture, there are a bunch of midpoints. I can tell this is a midpoint because it's congruent on both sides of there. This must be a midpoint because on that side of the triangle, it is also congruent on both sides. And this must be a midpoint because it is congruent on both sides of the triangle over there as well. Now, when we connect those midpoints, we get mid-segments. And every triangle has 3 mid-segments. You find the midpoints, you connect all of them, and you get the mid-segments. 3 mid-segments there. And we're going to talk about why these lines are interesting and what we can do with them and what we get from looking at them. Okay, so here's how the mid-segment theorem works. Now that we know what a mid-segment is, that segment that connects the midpoints of two sides of a triangle, that mid-segment, like DE there, which is a mid-segment, it is parallel to the third side. And when I say the third side, I mean the side that it's not touching. Notice that line DE, that red one that's going down the middle, is touching AB on the left, and it's touching BC on the right. So it must be parallel to the one that it's not touching, which is down there at the bottom, AC. So it's parallel to that third side always, and it will always be half as long as that side. For example, if this side down here is 2x, then that red line would be half as much, so it would be how much? X. And what if I had that this over here, instead of that, like what if I had the big this big line on the bottom was y, then how much would the mid-segment be? 1/2 y. It just means that that mid-segment will always be 1/2 of the side that it's parallel to. Always, always, always. That's what we're looking at. And each one will always be half of the third side that it is parallel to. So each one has its own unique relationship with the line that it's parallel to. Each one is half of that longer line. Okay, and then we're going to start doing something called coordinate proof. And when we do coordinate proof, what we're going to be doing is, instead of just putting things on an XY axis and graphing them, we're going to be graphing them when we don't even have numbers. We're going to be graphing them when they have variables in their coordinates, more than just numbers, because somebody will be like, well, how do I graph the coordinates 0, 2x? How the heck would I graph that? And that's what we're going to talk about today. It's actually way easier than it seems. So we're going to place geometric figures in a coordinate plane. We're going to use variables to represent those coordinates. And then those results will be true for all figures of that type. And what that means is that since we're using variables, this picture will be true and will give us the correct coordinates for anything once we know what x is. Like once we know what x is or what we know what y is, once we know what that variable is, we could figure out all of the coordinates and this picture would still be true. All right. Let's talk about this. It says triangles are used for strength in roof trusses. So this is like in your roof. Like if you have an attic and you've ever gone up there, usually they've got a whole bunch of supports like this. All these triangles are there to strengthen your roof because your roof is very heavy and it would probably collapse onto your house without all that support. So in this diagram, UV, where's UV? Here is UV right here. And VW, which is here, are mid-segments, meaning that they connect the midpoints. Here's a bunch of midpoints, and they're connecting the midpoints. So we know things about mid-segments. We know that they are parallel to the third side, and they are half the length of the side that they are parallel to. So our job is going to be to find the length of UV and the length of RS. So let's talk about UV. Yes, sir. How'd you get that?
Because the line that is parallel to is 9, and 9 divided by 2.
Okay, so check this out. We know that UV is parallel to RT and it's a midsegment. Therefore, UV is, watch how I take my words and I just turn them into a formula. UV is 1/2 of RT, that line on the bottom. I'm just making an equation out of it. UV is 1/2 of RT, but we know that RT is 90. Therefore, UV must be 45, which is exactly what he did in his head. He just condensed it all down there. So that's the red one there. But they also wanted to know RS. Now, RS is the longer blue line. What?
Wait, does it end?
Oh, whichever. Whatever you, yeah, I mean, but let's talk about how we get there, too.
You know that VW, you know that VW is like the mid-segment
Okay.
of SV.
Okay.
And SR.
All right.
Since VW is 57, you multiply it times 2, and then that's how you get SR.
Okay, so let me just turn that into a formula. We know that SR, the one that we're looking for, it's twice the length of VW, right? It's twice as long. So SR must be 2 times 57. And 2 times 57 is?
114.
114. Inches. So just by saying, like the thing, when we say things like SR is twice VW, that actually makes an equation. SR is means equals twice VW, in which case we could just plug right in. So let's fill in this chart based on that. Now here's a couple things. I'm going to use this chart, and we've got triangle RST and the midpoints of the sides ABC to complete this table. Now they've given me some information. I'm just going to write that information on here, and as we go, we're going to change some things. So AB is 12. That's this length right there. BC, which is on the bottom, is 14. That's this length right there. And AC is 18. That's this length right here. Based on that information, let's start by finding what? Yeah.
For A, like for BC and A, why does it say 14 but B 15?
Oh, I'm sorry. Let me clarify. We're doing this. There's going to be 3 separate scenarios here that they want us to look at. So my apologies. I should have been more clear there. So we're looking at just this first above that line there. I'm looking at those numbers. Then we're going to do this again for B and again for C. Thank you. Great question. All right. ST. ST is this line right here. How could I figure out what ST is based on that? Yes, sir. It's going to be half of AC, the one that it's parallel to. Half of 18 is what? 9. Somebody talk to me about RT, this line right here. You can just throw it out. You don't even need to raise your hand. It would be half of 12, half of the line that it's parallel to, since these are mid-segments. And half of 12 is 6. And what about RS, this one right here?
Half of 14.
It's half of 14, which would be 7.
Wait, are you able to write proofs with these?
We're not there yet. But of course, if it's a theorem, we could use it in a proof.
Theorem?
Yeah, the triangle midsegment theorem. Okay, now here's what I'm going to do. I'm going to move down to line B, and we're going to do this as if it's a whole new problem. So I'm actually going to keep my diagram. I'm just going to erase the numbers because this 12, 18, and 14 are likely going to change to a new set of numbers. Now I've got BC is, where's BC? BC is on the bottom, that's 15. So here's 15. AC is 22. And the other number that I know is that RT is 10. RT is this blue line right here. Let's start with A. Did I label the wrong one? 22 is AC. Yeah, I labeled the wrong one. My apologies. I was just about to say I already have that number. This should be AC there. That's 22. So they want me to find AB. Looking at this diagram, how can I find AB using the mid segments? Susie?
Because they give much. You just do RT times 2, which is 20.
Beautiful. Let's keep going for ST. That's the little red line. Keep going. Yep.
ST is half of AC, and you know AC is 22, so you just do 22 divided by 2, which is 11.
Okay. And somebody different talk to me about RS. That's the short green line. Yes, sir.
RS would be 7.5 because it is parallel to BC.
Good. It's parallel to BC, and BC is 15. We'll do one more line here. We're going to do the last line there, that last one that starts with 10. So I'm going to erase my numbers one more time and just do some replacing of numbers. Okay, now we've got AB is 10. We've got ST, which is 9. And we've got RS, which is 7.8. All right, well, they want BC first. BC is the green line on the bottom, the big green line. Take it.
BC is twice as much as RS, so you do 7.8 times 2.
Okay, 7.8 times 2. Do you want to take a second, or you got it?
Wait, what?
So what is 7.8 times 2?
I think it's like 15.6.
It is 15.6. 7.8 times 2, because it's parallel to the other green line. RS is the mid segment, so BC must be twice as much as that. How about AC? Somebody different give me AC, that red line over there on the big red line on the left.
18.
18, how'd you get that?
9 times 2.
Right, since it's parallel to the mid segment that is also red, it is 9 times 2, which would be 18. And then finally RT, which is the little blue line. 5. It's half of the bigger blue line, which is, since RT is the mid segment, it is half as big as the one it's parallel to, and the one that it's parallel to is 10, so it's half as much. All right. This says place a rectangle in a coordinate plane so its vertical side has a length of A and its horizontal side has a width of 2A. Label the coordinates of each vertex. So what I'm going to do is I'm going to bring in a blank graph here because I want to bring it in and be able to graph it, and I'm not great at drawing graphs myself, so I'm just going to bring this in. But this one already has numbers on it, and since we're going to be working with variables, I just want to cover up, let me just, bless you. I'm just going to cover up the numbers because I don't want the numbers. So I'm taking,
Why don't you want the numbers?
because what we're going to be graphing here is variables.
Oh, okay.
So I just wanted a graph, and the one that I had numbers on it. So I could search for one without numbers, and that would be just as good. But I'll show you what I mean here in a minute. Why the numbers are actually not going to be good for me. Okay, so I just cleared it off there so I could look at it. Now we're going to graph something on here that has variables, and that's a little bit difficult because we never graphed variables before. It says place a rectangle, that's an important piece of information, in a coordinate plane so its vertical side has a length of A, so the vertical side has a length of A, and its horizontal side has a width of 2A. Label the coordinates of each vertex. Well, to do this, we're going to cheat a little. There's one point that we're always going to use, and when we put these shapes on there, we're always going to use 0, 0 as one of our points. So here's one of our points at 0, 0. And I'm going to do this now based on that. I'm going to do that in black because yellow doesn't show up as well. 0, 0. That's the first point of my rectangle. Now the vertical side has a length A, which means I'm going to go up A units. How long is A? We don't know, so I'm just going to pick something. I'm just going to go up, I don't know, here. Okay? I'm going to call that A. That's A units up. All right? So this length here is now A. Cool? I just went up A. That's all I did. And its horizontal side has a width of 2A. Well, that means that this side on the bottom, however long I make this bottom one, needs to be twice as wide. Because if that one's A and this is 2A, it's twice as wide. So let's go twice as wide there. This is 2A. I made it twice as long as I did tall. But notice that is not a rectangle. I'm missing a point for a rectangle. Where's that last point going to go? Yes, sir?
It's going to go in line
right there. That's where it's going to meet up. That's the missing point of this. Now, we know one of these points. One of these points is 0, 0. That's this coordinate right there. Well, guess what? This point right here, that one right there, how many units did I go to the left and right?
8.
For this one right here, how many points did I go? How many units did I go left or right? I'm going to give the coordinates of that point.
Wait, what point are you talking about?
The one that has a circle and an arrow.
Oh,
That one. So think about, we usually do our x coordinates first, right? How many units to the left or right did I go? 0. But here's the confusing part, and please do not answer right away unless you've really thought about this. How many units did I go up? A units. Just because I went up 4 lines, don't say 4, because I just made that up. How long is that? I went A units up. So its coordinates are 0, comma A. How about this one down here? How many units to the right did I go? 2A, and I went 0 units up and down. Well, then what the heck would be these coordinates?
2A, 0.
Good, I went 2A units to the right and A units up. Notice the only one there that actually involves real numbers for both of them is 0, 0. But I couldn't have done it without that point. Using 0, 0 as kind of a basis, a jumping off point, I went A units up and 2A units to the right. And because of that, I have my coordinates. The coordinate in the lower right is 2A units to the right and 0 units up and down. The one in the upper left is 0 units left or right and A units up. Using those other 2 points, I go, oh, now I know what my last point has to be because it's a rectangle. I'm going to stop us there, and I will finish the last 2 slides like after school today. I will upload those immediately so that you can get finished on the last of your homework. But that's actually the majority of everything that you're going to need for your homework. I'm going to do the last 2, which take a little bit longer. So you'll have that tonight. Just watch, for you guys that are here, just watch the last 2 slides. That's all you're going to need. And they got to the same point. Okay, for the next one, we're going to sketch triangle ABC. It says find the length and the slope of each side, then find the coordinate of each midpoint. Is triangle ABC a right triangle? Is it isosceles? So we're going to look at all those. We're probably going to need, to be able to determine whether it's a right triangle, we're going to need to know whether it has a right angle in there. To know whether it's isosceles, we're going to have to know the length of the sides of the triangle. So we're going to take a look at that. So I'm going to put on these points here. We've got A is equal to 0, 0. So that's 1 point in our triangle there. There's A at 0, 0. And we've got B, which is at HH. So it's a certain amount of units to the right and a certain amount of units up. Now, I don't know what that is. HH is not a number, it's a variable. So I'm going to go a certain amount of units to the right and the same amount up or down. So I'm just going to use, we've got 0, 0 here, just to, let's make that 3 units to the right and 3 units up. Now, I just picked that number randomly as a part of here. It could have been 4, 4, it could have been 1, 1, it could have been 2, 2. I'm just using a point here to help that to help build this. So the next one that was point B, and its coordinates are H, H. Now for C, I need to go 2 times as much to the right. Remember that B was H units to the right, and C is 2 times that amount to the right. So instead of going, now I made that 3 units to the right, and we'll go 6 units to the right. So that's 2H units to the right and 0 units up or down. So we have this coordinate here, which is at 2H, comma 0. And remember that 2H doesn't mean it's 6 units. It doesn't mean it's 6 units. It could be any number in the world. But I just made it doubly as far as the first one was to the right. So B was H units to the right. This was 2H to the right. So I had to go twice as much as I did before. So we have this triangle that looks like this. Now, if there is, first of all, it asks whether this is they want the coordinates of the midpoints first of all. So let's find the coordinates of all the midpoints. We'll start with line segment AB. So we're going to use the midpoint of A and B, and remember that's going to be x1 plus x2 over 2 and y1 plus y2 over 2. So our coordinates here, let's use x1, y1, x2, y2. And we've got 0 plus h divided by 2. And for y, we've got 0 plus h divided by 2. So 0 plus h will just be h. Get h divided by 2 and h divided by 2. Now we don't know what h is, that's just a variable. So the midpoint of line segment AB, so here is the midpoint of line segment AB, is h divided by 2, h divided by 2, or h over 2, h over 2. We also need, so let's look at that one on the right now, that would be BC. So BC, we're going to look for the midpoint of line segment BC. Now BC, since I already have an x2 and a y2 on B there, I'm just going to make this x1, y1. Because remember, it doesn't matter which one we call the first set and the second set. So we are going to do the midpoints. So we've got h plus 2h, that's adding the x's together and dividing by 2. And for the y's, we've got h plus 0 divided by 2. H plus 2h would be 3h divided by 2. And h plus 0 would be h divided by 2. That is the midpoint of BC, would be 3h over 2 and h over 2. So remember, those aren't numbers, they're just, if you tell me how long h is, I can tell you where the midpoint is by plugging it into this little formula there, or here, depending on which one. Now finally, the only other one we're missing is the midpoint of that bottom right there. Now, if you think about this here, we should be able to figure it out fairly easy here. We've got AC on the bottom, so we're going to use A and C. Now, A has an x1, y1 on it, and C I wrote x1, y1, so I'm just going to change that C to an x2, y2 for a moment. And for the midpoint of AC, we've got 0 plus 2h divided by 2. That's the adding the x's together and dividing by 2. And for the y's, I've got 0 plus 0 divided by 2. So the midpoint for this should be 2h divided by 2. Now if you think about that, 2h divided by 2, I can cancel out those 2's there, and I would just be left with h. And over here, on the right-hand side, I've got 0 plus 0 divided by 2. Well, 0 plus 0 is 0, and 0 divided by 2 is still 0. So the midpoint of AC would be h, comma, 0. H units to the right, 0 units up and down. And if you think about it, it makes sense, because look at that bottom line there. If you went all the way to the right, that would be 2h units long. If you went to the middle of that, that's half as much as 2h. That's only h. So that makes a lot of sense. So we found the coordinates of each midpoint. We need to know whether it's a right triangle. Well, looking at this, the only possible area where there might be a right angle is right there. Now, I'm not saying there is. I'm just saying if there is, it's right there. So we're going to look at the slopes of these two lines right here, AB and BC. If they form a right angle, then those two lines are perpendicular to each other. They form 90 degrees, and they will have the opposite reciprocal slope. So I'm going to find the slope of each of these. So let's do AB, the one on the left. Here's x1, y1, and we'll call this x2, y2. Remember, to find the slope, we're going to use y2 minus y1 over x2 minus x1. So we've got y2 is 0 minus y1 is h divided by x2 minus x1. So we've got 0 minus h over 0 minus h. So right there we've got, if you take 0 and you subtract h, we just end up with negative h on top. and 0 minus h on the bottom, we would end up with negative h. Well, a negative over a negative will always be a positive, so we get h over h. And remember, anything over itself, as long as that denominator isn't 0, because we can't divide by 0, will always equal 1. So the slope of that line there is 1. And that kind of makes sense, because look at it. It goes up 1 over 1, up 1 over 1. That makes sense. So if these lines are in fact going to be perpendicular, then the other one should have a slope of negative 1. It's going to go down 1, right 1, down 1, right 1, which it looks like it does, but I'm going to test that out with the actual numeric values here. So here's going to be my x2, y2, and we're going to use y2 minus y1 over x2 minus x1. So what we get here is 0 minus h is negative h, and on the bottom, 2h minus h would just be a 1h. Now, a negative over a positive will always be negative, and h over h, something over itself, will be negative 1. Notice one of the slopes is 1, the other one is negative 1. These two slopes are opposite reciprocals, meaning that this is, in fact, a right triangle. Is it isosceles? Well, we would need to use the distance formula on AB, the one on the left, and BC, the one on the right. So we're going to do that next. So I'm going to use the x1, y1 that are actually there, because if it's isosceles, it's going to be those blue ones there. We can kind of see that right there, that those two are the ones that are set up. I mean, if you think about it, here we already know this is a right angle. So if it is going to be true that any two are going to be congruent, it's going to be those two legs that are touching them, right? Because then the base angles would be congruent. We can't have two other angles we can't have another angle that's 90 degrees. Then we would have 180 with 2 degrees. So with two angles, I mean. So we're going to take a look at AB first of all. So AB, the distance of AB, is going to equal the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Plugging in here, we get x sub 2 is 0 minus x sub 1, which is h squared, plus y sub 2, which is 0, minus y sub 1, which is h squared. So we're just doing that line on the left. Again, this is AB. So let's work this out here. So we've got 0 minus h times 0 minus h. We're actually going to square it. Like what we've got there is 0 minus h would give me negative h, and then we're going to square it. And then over here we've got negative h, and we're going to square it. So what we end up with is h squared plus h squared. AB is equal to the square root of 2h squared. Now, if you think about that, we could break that down to 2 times h squared. Well, I don't know the square root of 2. That's not a number that I know. It's not something I can break down. But actually, h squared is something I know. What times itself will give me h squared? That's just h. So we're going to actually pull out an h to the front. So we've got h times the square root of 2. So the distance of AB is h square root of 2. So you can see this is getting a little bit complicated here because we've got variables in there. So I don't know what that distance is, not until you tell me what h is, but we are going to still see if BC is congruent to that, because if it's congruent, it doesn't matter. We've got an isosceles triangle, so let's do BC. So I'm going to use these numbers here, x1, y1, and x2, y2. So I'm working on the blue line on the right. So BC is equal to the square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, which gives us x sub 2 is 2h minus x sub 1, which is h, plus, that's squared, plus y sub 2, which is 0, minus y sub 1, which is h squared. 2h minus h would just give me h, and that's going to be squared, plus 0 minus h, well, I'm going to have 0 minus h, which will give me negative h, and that will be squared. So we get the distance of, the length of BC would be h squared plus h squared. This is good news here because remember, we had h squared plus h squared right there. So this is going to be BC is equal to the square root of 2h squared. Well, I remember that. I remember I can take out the square root of h squared, which would just be h, and left hand side would be the square root of 2. These definitely have the same distance. Now that distance is h times the square root of 2. Without knowing what h is, we can't give an exact number, but they're definitely the same length. They are h square root of 2. So long problem there. Is it isosceles? They sure are because 2 of the sides are congruent. It's an isosceles right triangle based on that. That was a long problem, a lot of work there. Last but not least, use triangle GHJ where A, B, and C are midpoints of the sides. GH is 7x minus 1 and BC is 4x minus 3. What is GH? So let's draw us a little triangle here. GHJ, just so we can get an idea of what's going on. Now, one thing that would be needed for this problem, it's actually not listed here, but this is definitely important and this would need to be included in the notes. What is missing here is that they need to tell you where the midpoints would go, because the midpoints, they don't tell you where A goes, where B goes, and C goes. Now, I'm just going to tell you right now is that we're going to put A right here. Now, trust me, I would have to give this to you. You could not have just guessed this. This is me just telling you that these midpoints would have to look something like this, just because I've worked this problem out and that piece of information is missing here. So those are the midpoints. Now, they said that GH, this length right here, GH, is 7x minus 1, and BC, this length right here, is 4x minus 3. Now, remember, what we've got here is midpoints. These are the midpoints. They've told us that. So that means that this line BC that it is connecting is a mid-segment, which is actually a very useful piece of information. Because BC is a mid-segment, it is half of 7x minus 1. Or, if you'd rather write it this way, I actually think it's easier to do it this way. We've got GH, that longer line there, GH, so GH is twice or 2 times the size of BC. Remember, GH is 2 times the size of BC. We know that. So let's just plug in now. 7x minus 1, that's GH, is equal to 2 times BC, which is 4x minus 3. 7x minus 1 is equal to 2 times 4x is 8x, and 2 times negative 3 is negative 6. I'm going to subtract 7x. You know what I'm going to do is I'm going to carry this right over here. I'm going to subtract 7x from both sides, and I would get negative 1 is equal to x, because that's 8x minus 7x minus 6. And then I'm going to add 6 to both sides, and I get x is equal to 5. This is a place where people often leave their answers, but it would be incorrect because it asked me what is GH. So they want to know how long is GH, meaning I need to take that 5 and plug it back in right over here. 7 times 5 minus 1 is 35 minus 1. This is 34 units long. And that's it.